In this video, we're going to continue with section 2.2. And the first thing we're going to talk about are relative maximum or minimum values. A relative minimum value, you can think of it as kind of a low point in the graph, and a relative maximum value would be a high point in the graph. Another way to think about it is that they occur at points where a function changes its increasing or decreasing behavior. So for a relative minimum, the function is changing from decreasing to increasing at that point. And at a relative maximum, the function is changing from increasing to decreasing. Now, a couple of important things when you're doing problems about this. When the question asks for the number at which the function has a relative maximum or minimum value, that's going to be the x-coordinate. The relative maximum or minimum itself is the y-coordinate of that point. So we're going to look next at one of the homework problems, exercise 13, because there isn't an example in the textbook over this idea. First, I want to show you in the homework, if you haven't already seen this, when you have a graph in the homework, sometimes the graph is really small, and if you're trying to pick out the points, it might be kind of hard to see. So obviously you can make your window bigger, but another thing that you can do to make the graph easier to see is use these buttons here on the right side of the graph. We have the magnifying glass with a plus sign that's going to zoom in on the graph right in the window. Sometimes it makes it so that you have to scroll to see the entire graph, but clicking on this a few times can make the graph easier to read. Another option is this bottom button with the arrow. That opens the graph in a new window. And so if I click on that, now I can see the graph a little bit more clearly. I can get my answer in my mind and then click on OK to go back to the window with the homework problem. So again, if a graph seems like it's too small, try one of those things to make it a little bit easier to read. So for exercise 13, we're using this graph to find each of the following. A says to find the numbers, if any, at which f has a relative maximum. Now looking at the graph, a relative maximum is right here. And when they ask for the numbers at which, that's asking for the x-coordinate. So looking at that point, the x-coordinate of the relative maximum is 0. When it says to find the relative maxima, now that's asking for the y-coordinate. And the y-coordinate of that point is 4. Now, one thing about relative maxima or minima is that they might not be the highest point on the overall graph. So looking at this graph, this point is the highest point in this area, but the graph is going to go higher on either side where the arrows are. It's going to just keep on going up and up forever. So it's not the highest point on the whole graph in this case. It's called a relative maxima or minima. Sometimes you'll see the words local max and local min. That just means that it's the highest point in that area. Question B says to find the numbers at which f has a relative minimum. So looking at the graph, I can see that there's going to be a relative minimum here and another relative minimum here. So find the numbers at which it has a relative minimum. That's the x-coordinates, and the x-coordinates for those points are -3 and 3. If there's more than one, you're going to just list them with a comma in between. And part B says to find the relative minima. Now that's the y-coordinates. Both of those points have the same y-coordinate, so I only need to type it once. It's 0. Our next topic is even and odd functions, and we're going to be determining whether a function is even or odd by looking at the graph. Even functions are symmetric around the y-axis. So if you think of the y-axis as a line of symmetry, the graph will be a mirror image on either side. An odd function is symmetric with respect to the origin. This is a little bit harder to see, but what you want to think about is if you take this piece of the graph and rotate it 180 degrees, it's going to line up with the other part of the graph. So odd functions are a rotational symmetry. You're not flipping it over, you're just rotating 180 degrees. And even functions are a reflection symmetry, so you can think about flipping the graph over the y-axis. So in example 4 in the textbook, we're asked to determine whether each graph is an even function, an odd function, or neither. So looking at A, what I can imagine is rotating this little V-shaped part here around 180 degrees, and it's going to line up exactly on top of this V-shaped part down here. So if I move this 180 degrees, it will line up perfectly, and that means it's an odd function. For part B, I can imagine flipping over the y-axis. If I take this part and flip it over the y-axis, it's going to line up exactly with the other part, and so that means this is an even function. For part C, now if I rotate it, it's not going to line up with any part of the graph down here. And if I flip it across the y-axis, it's not going to line up with anything over here. So this means it's neither even or odd. So next you should do checkpoint problem number 4. Do these in your notes, check your answer, and then move on with the rest of the video. So next we're going to do a putting it all together type of problem. You'll have one of these in your homework as well, where we're using the graph to find all of this following information. So the first thing that we're going to look at is the domain of f. Now, remember when you're writing domain, we're going to write it in interval notation. In MyLab Math, they give you little instructions, it's usually in a blueprint, about how to enter your answers. Make sure that you pay close attention to that, especially when it comes to quizzes and exams, because you don't want to be losing points because you're not entering the answers the way that they want them to be entered. So for the domain of f, we're looking across the x-axis, and I can see, because of this downward pointing arrow here, that I'm going all the way out to negative infinity. And my highest point is 3. And because there's a solid dot there, the 3 is included. So my domain, I always use parentheses around infinity. So it's negative infinity, comma, 3, with a square bracket around the 3. Now for my range, on the lower end, it's also going to go to negative infinity because of this downward pointing arrow. My highest value is going to be 4. And again, I'm going to have a square bracket around the 4 because I can assume that that point there, where it looks like it's touching 4, it actually is touching 4. So my range is going to be parenthesis around negative infinity for my lowest value. My highest value is positive 4 with a square bracket. Question C is asking for the x-intercepts or zeros. The word zeros means the same thing as the x-intercept, or where the graph crosses the x-axis, and we'll be seeing that a little bit more later on. But looking at this graph, I can see that it looks like the graph crosses the x-axis at negative 3, and here again at positive 3. So those are the x-intercepts. Again, remember, we just list the numbers of the x-coordinates. We're not writing those in points. The y-intercept is right here, where the graph crosses the y-axis. That's at positive 3. The intervals on which f is increasing. Remember, for these, they're always open intervals, and constant as well. Increasing, decreasing, and constant, we use open intervals, which means we use parentheses always. So f is increasing, it looks like all the way up to 1 And that point at 1 is where it turns around and starts decreasing. So it's increasing from negative infinity up to 1 with parentheses around that, and it's decreasing from 1 to 3. And it doesn't look like there's any point on this graph where the graph is constant. So I'm going to write none. The number at which f has a relative maximum, well, this is that relative maximum point right there. That's at 1. And the relative maximum itself is the y-coordinate, so that's going to be 4. We have f of 2. Remember, this is the y-coordinate when x equals 2. So I find x equals 2. I go up to the graph. That's this point. The y-coordinate there is 3. The value of x for which f of x equals negative 2. So negative 2. I find that on the y-axis. And then I go across and I find the x-coordinate there. So that point on the graph, the y-coordinate is negative 2 when x equals negative 4. Or you're probably just going to type negative 4 into the box for that one. And the last question, is f even, odd, or neither? So now I'm looking for, is it symmetric around the y-axis? So is it a mirror image? Well, no, it's not. And I can't rotate this part of the graph and have it line up with a part of the graph down here. So the answer would be that it is neither even or odd. So next you should take a look at the homework for this section.